Today we're looking at Glencoe Course 2 Math, Lesson 5.5 on adding expressions. Simplifying expressions, however we do that, is all about writing what we're given using fewer terms. So, when cell phones first came out with text messaging, you got 140 characters per text message. And if you went over 140 characters, it counted as 2 text messages, and back then you were charged by the text. Okay? They didn't have unlimited texting. So you had to limit the number of characters that you used. Now that same philosophy is used with Twitter. Okay? When you send or post a tweet, you have 160 characters. You can't go more than that. It won't let you post it. So our goal is to have the fewest number of characters possible while representing the same quantity. That's what we're trying to do. Alright? Sometimes we have multiple expressions in the same problem. Those multiple expressions are separated by using parentheses. So the associative property is being used to say this group is one expression, this group is another expression, and we're going to combine them to limit the number of characters that we have to write. Okay? If we look at example 1 on page 396, we have the two expressions, 2x plus 3 that's one expression. We know that that's an expression because it has parentheses around it. That is grouped together as one thing. And we are going to add to that x plus 4. Okay. When I combine these, because I can, the first thing that I'm going to do, I'm going to use a combination of the associative and the commutative properties to eliminate my parentheses and put my like terms next to each other. So, I'm going to start with 2x plus x plus 3 plus 4. 2x plus 1x gives me 3x. And I'm going to add to that 3x, 3 plus 4, which is 7. I cannot combine x's and 7's because I don't know what x represents. It could be 1, it could be 3 million, it could be, 5/8. I don't know. And it really doesn't matter. Because as long as that variable stays as an x in this problem, it represents the same quantity. In another question, x could represent a different number. Okay? But what we started with was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 characters. I know a lot of us don't like math. If you're going to rant and rave about how much you don't like math, you don't want to be using 12 characters to be able to do that. 1, 2, 3, 4. This uses a third in this example. So we have 4 characters with 2 terms instead of 12 characters with 4. Does anyone have any questions about what we started with and how we got to our solution? Okay. Then let's jump ahead, and I would like for us to look at example 4. Example 4 says, now we need to find the solution to 2 times the quantity x plus 3 plus 3x plus 1. So I have 2 times the quantity x plus 3 plus 3x plus 1. This time I have to use the distributive property first. I'm going to distribute this 2 to the x and the 3 inside this set of parentheses. Now this 2 is strong enough to go towards everything in this set of parentheses, but it is not strong enough to go all the way over to the second set. So the 3x plus 1, we're going to leave alone. You have 2 times x and 2 times 3. We're going to add to that 3x plus 1. When we simplify 2 times x, I'm going to write that as 2x. 2 times 3 is 6, plus 3x plus 1. Now I have 4 terms. I have 2 x values and I have 2 numbers. I'm going to rewrite my problem using the commutative property so that my x terms are next to each other because they're alike, and then my number terms are together. 2x plus 3x plus 6 plus 1. 2x plus 3x is 5x, plus 6 plus 1 is 7. So I started out with this. It's long, it's got a whole bunch of parentheses, it's got operations inside parentheses, it's got operations between parentheses. That's a really long way of saying 5x plus 7. Being a mathematician and being lazy, I would rather write 5x plus 7. Because 5x plus 7 is the same quantity that I started with. Do we have questions?
No, ma'am.
Yes, sir.
I don't understand the sentence in the
This part? Going from here to here or here to here? Here to here? Okay. What I did going from here to here, I took my x's. Just like if I had 2 x boxes and 3 x boxes. Okay? X is some unknown amount. Okay? So I have 2 of those plus 3 of those. That means that I have 5 total. Here I have the number 6 and the number 1. 6 plus 1 is 7. I cannot combine x boxes and numbers. I can't count them the same way because they're different. Now, is this really representing x boxes? No. This represents some unknown value that I have 5 of. So if I was going to expand this, this would be the same as x plus x plus x plus x plus x plus 7. Okay? I can't combine those things because I don't know how much this x is. Okay?
So you just can't count it?
Nope. Well, I did count it. I counted it as 5x. Because I have 5 of that value. Okay? We good? Fantastic. Any other questions? Okay, there's one more example that I would like for us to look at today. I'm sorry? Can I erase the blue? Okay. The last example that I would like for us to look at today is example 5. Example 5 says, find 5 times the quantity x minus 4 plus minus 7. Hold on, I'm missing a variable in there somewhere. 2x minus 7. Okay. I see 2 issues to start out with that are going to make this a little bit more difficult at the front. The first thing I see, I'm going to have to use a distributive property because I have a number directly outside my parentheses. Okay? The second thing that I see subtraction signs. And subtraction signs means that I cannot use the associative property. I cannot use my commutative property. But I can, KCA, change those subtraction signs to addition signs and use the additive inverse of that second term. So I'm going to go ahead and KCA first, and then we will use the distributive property. So this x minus 4 becomes x plus a negative 4. 2x minus 7 becomes 2x plus negative 7. That took care of that issue, so now I can use all of my properties. Now I have all of my tools available to me to simplify this. Using the distributive property first. 5 times x, 5 times negative 4. And I'm going to add to that my 2x plus negative 7. I need to simplify so that I only have addition signs. 5 times x is 5x plus 5 times negative 4 is negative 20 plus 2x plus negative 7. I don't like that. I've got variable terms and numbers and variable terms and numbers. I don't like it like that.
I don't like it either.
Me either.
You don't like it either?
No, I
Okay.
think it's like a bit complicated.
So then, let's use our commutative property and rewrite this so that my like terms are next to each other.
Sure.
5x
That sounds wonderful.
plus 2x plus negative 20 plus negative 7. 5x plus 2x is 7x. Negative 20 plus a negative 7 is negative 27. Yes, sir. Wait just a second. Now, there is one other way that I can write this. Because I'm trying to cut down on the number of characters that I use. I've simplified the number of terms. I'm down to 2. I like that part. But I can still simplify the number of characters that I use without changing the value. I can write that as 7x minus 27. Do these two things mean the same thing? Yeah. Does it matter which way that I write it in the end? Does it matter which way it's written when we start?
Oh. Yeah.
Yeah. When we have that subtraction sign, I cannot use my associative and my commutative properties. But at the end, I could put that subtraction sign back in there. Are there any questions? Alright, when we do our work with this, how many lines did it take me to solve these? 1, 2, 3, 4. 1, 2, 3, 4. That justified my answer.
4 lines.
It took me 4 lines. When we didn't have to distribute, it took me 3. Can you give me just an answer?
No.
No. You need to show me your work.
Well, you can, but that would be wrong.
You need to show me how you get from here to here. Okay?
Show you.
So, when we set up our problem, we have problem, work, solution. The solution becomes our problem, work, solution. Problem, work, solution, which is the problem, work, solution. You need to show me all the work. When we're simplifying expressions, it's really easy to forget a negative, to put the variable in the wrong spot, to forget a variable if you don't do that. Okay, any last questions? Thank you.